Name the refining method used for silver and gold. For the silver and gold, we always go with the electrical arc method or a electrical refining method, which gives a 100% pure metal. How the nickels are extracted? So nickels are mainly extracted by a Mons process, which is nothing but a refining techniques only. There are mainly 3 steps are involved in extraction of the iron. They are combustion zone, reduction zone and the zone of slag formation. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, today we are going to start with the revision for the Unit 6, General Principle and Process of Isolation of Elements. Let us see what we are going to discuss in this unit or what is all about this unit. Okay. So, in this unit, we shall describe various steps involved in effective concentration of ore. So, this unit will be everything about the concentration, extraction and purification of ores which has been obtained naturally. Okay. So, in the concentration of the ore, we will follow the different types of techniques with a suitable example. For example, we follow the magnetic separation, we follow the froth rotation, okay. So, and gravity separation method. These are the different types of techniques that we follow only for the concentration of ores, okay. Next, after that, we shall discuss the principles of some of the common metallurgical process. So, which are the principles which is very much common to get extracted metal from its ore, okay. So, we have a metallurgical principle for that, which are those that we are already discussed in the concept class. So, please do watch with that, and those principles shall include the thermodynamics as well as with the electrochemical aspects. It is very important. So, in earlier days, they used to use a thermodynamic aspect to select the reducing agent. Now, by using electricity, we can use the suitable reducing agent for the extraction of metal, and also for the purification. Nowadays, we are going with the electrochemical aspects for the effective reduction as well as with the concentration over to the metal. So, hope you all understood what is about the metallurgy and the extraction of the metal too. So, from this unit, we can expect only 4 mark, that is 1 question from the part A, that is a question number 8, and we can expect the 1 question in a part C, that is for the question number 26. Hope you know that this is a unit for the inorganic chemistry. So, we can expect only 3 mark question. There will be a 2 mark question, but this 3 mark question can also be split as 2 plus 1 or sometime 1 plus 1 plus 1 also we can expect. Let us see what are the 1 mark and 3 mark questions which has been repeatedly asked from this unit. Okay, and in this unit, we have to know which concentration methods we are using, which is the reducing agent we are using, which methods are following for which ores, everything. It is very common because we can expect 1 mark question randomly from this unit. Okay, name the ore of alumina, okay, or aluminium. So, the ore of aluminium, hope you know that in the extraction of the aluminium, we take the bauxite ore, which is the ore of alumina or aluminium. Okay. Give the composition of copper pyrites. So, we know that copper pyrite, it is nothing but a combination of copper with FeS2. Okay. Name the electrolyte which is used in extraction of aluminium. So, we use electrolyte specifically called as molten aluminium oxide and a cryolite and CaF2, that is nothing but calcium difluoride. Next, what are the product which is formed when a calcium carbonate is calcinated? Remember, when a calcium carbonate, if you are calcinated, we can expect calcium oxide plus carbon dioxide. Okay, so this is during the extraction process. We'll go with the calcium containing ores for the calcination method. So where it always liberate the carbon dioxide gas. Next, give a composition of copper matte. So the copper matte is different from the copper pyrites. Okay, so see the composition. It is nothing but cuprous sulfide with FeS. Next, what do you mean by blisters of copper? So during the extraction of the copper, as I explained in my concept class, blisters of the coppers are nothing but the bubbles of the coppers which has been obtained at the end of extractions. So which is nothing but copper only. So solidified copper which are obtained as a blisters appearance due to the evolution of what? Sulfur dioxide gas, that is known as what? Blisters of copper. So during the extraction, what will happen? The sulfur dioxide will be evaluated out. Due to that evolution of the sulfur dioxide, the blisters which has been formed on the collection chamber of the copper, which we also call it as what? Blisters of copper. Next, which metal is refined by Van Arkel method? So like this, during the extraction method or during the purification method or during the concentration of the metal, which metal can be extracted or concentrated? Like this, plenty of question can be expected from this unit. Better to go with the each type of the ore that we use for the extraction of which metal we are obtaining. Everything you must know in detail. The metal which are refined by the Van Arkel method is nothing but titanium and zirconium. Name the process which are usually employed for purification of nickel. For the purification of the nickel, as I explained, we go with the Mond's process. Name the refining method used for silver and gold. For the silver and gold, we always go with the electrical arc method or a electrical refining method which gives a 100% pure metal. Next, which type of ore is concentrated by froth flotation process? So we know that from the froth flotation process, always sulfide form of the ores will be taken. Okay. Next, how is pure alumina is obtained from bauxite by a leaching process? This 3-mark question, we can expect repeatedly as many as times, it has been asked for your board exam. And for this extraction process, or for the leaching process, you have to write the 3-step. I'll show you how to write it. Okay. So first of all, we have to take the ore of alumina, that is nothing but a bauxite ore, that is nothing but Al2O3. When it be treated with the sodium hydroxide in presence of water, what will happen? It forms a complex known as sodium aluminate. Okay, it forms what? Sodium aluminate. So this is sodium aluminate. This is a first step. In the second step, the sodium aluminate are allowed to pass with the carbon dioxide. It forms aluminium trioxide with the formation of sodium bicarbonate. This aluminium oxide, the precipitated of hydrated aluminium oxide is separated by filtration, then precipitated is dried and heated strongly to get a aluminium oxide. We will take this precipitate and we strongly heat at very high temperature to eliminate this water. When we eliminate this water, we get a aluminium oxide. This is how the aluminium oxide or purest alumina is obtained from the bauxite ore. Next, explain zone refining method. So obviously we already know that what is mean by zone refining. Zone refining, it mainly based upon a principle called as impurities are more soluble in a molten state than in the solid state. Based on this principle, we will select the metal and we use a circular coil. Okay. So from one end, we started moving the circular coil to the end so that if any impurities which is there in this metal rod, it will be condensed in the molten state and it will be collected at the one end. So this process will be continuously we are doing for the many times until unless all the impurities are removed, and once the impurities are collected at the one end, we will cut this entire metal. This is known as what? Zone refining. The impurities are soluble in molten state than in solid state. This is a principle. And moving the electrical coil is fixed at one end of a impure metal rod. On heating the pure metal, which is solidified, while the impurities are passes from the molten zone, and this process will be repeated for the several times. This method used to get ultra pure metal. So from this metal, we get ultra pure metal which do not contain even a small quantity of impurities also, and it is mainly used to produce as a semiconductors like germanium as well as with a silicon. So they can ask you, so from the zone refining, which are the semiconductors are produced? So it is germanium and silicon. Or what is the principle which is involved in zone refining? Like that also the question can be raised. Next. So just now I have explained in a 1 mark question how the nickels are extracted. So nickels are mainly extracted by a Mons process, which is nothing but a refining techniques only. Okay, in this refining techniques, we will take the crude metal of the nickel and we started heating with a carbon monoxide. It forms a complex compound which is nothing but nickel tetracarbonyl. Nickel tetracarbonyl. This nickel tetracarbonyl is an unstable one which decomposes to give nickel and carbon monoxide. So this process of obtaining a pure nickel from the Mons process, it is very important for the purification method for the nickel. Next, explain the Van Arkel method for the refining of zirconium and or titanium. So just now in the 1 mark also I have discussed that name the metal which has been purified or refined by a Van Arkel method. So from the Van Arkel method, we are applying only for D block element, that is zirconium as well as the titanium. So we'll see with how do they get pure. Crude metal is heated with iodine to give a tetraiodides. On heating the tetraiodide, which gives a metal. You can see that we are taking the zirconium. You can take the titanium also, which has been heated with the iodine, which forms what? Metal complexes are formed or tetraiodides are formed. So this tetraiodide, which decomposes to give metal, pure metal with the iodine gas. The metal are used in the space technology or purified by these methods. Okay, like this, or zirconium or titanium can be purified by Van Arkel process. Next, we have write down the reactions which are taking place in a different zone of blast furnace of extraction of iron. We can expect this question also, or sometime they'll ask what is a role of calcium carbonate as well as with the limestone, which is nothing but a charge. Okay, what are the roles in the extraction of iron? Or sometime they ask you what is a slag for the 1 mark, or they'll ask what is a pig iron for the 1 mark also. Okay, so as we already know that there are mainly 3 steps are involved in extraction of the iron. They are combustion zone, reduction zone and the zone of slag formation. We'll see with the combustion zone once again. At the bottom of the furnace, the carbon is burns with the hot air and gives a carbon dioxide which moves upward and meets other carbon atom and converted into carbon monoxide. Remember, this is the structure of the blast furnace, correct? So from the bottom, we are going to supply the hot air and we have taken the mixture of the charge here, which is nothing but your ore along with the limestone along with the calcium carbonate. Okay, when we apply the hot air from the bottom, the carbon burns with an oxygen and forms a carbon monoxide. Okay, so firstly it forms a carbon dioxide. Later that carbon dioxide, as it is moves upward in the furnace, it combines with the remaining carbon and forms a carbon monoxide. So in the second step, at the top of the furnace, carbon monoxide will be used as a reducing agent which reduces iron oxide into iron. Your iron oxide will meet with the carbon monoxide, and forms a iron with the evolution of carbon dioxide. At the last step, as I said, we have taken the limestone along with the calcium carbonate. Limestone will be decomposed to give a calcium oxide and a carbon dioxide. This calcium oxide combines with the impurities in the form of silicon dioxide, it forms a calcium silicate. The formation of the calcium silicate, it is known as what? Slag, and it will be collected at the one end. So from this process, you know, the iron which we obtain, which we also call it as what? Pig iron. Draw the neat label diagram of a Hall-Heroult electrolytic cell of a extraction of aluminium and write the anode and cathodic reaction. So this is an entire setup for the Hall-Heroult extraction of electrolytic cell, and it consists of a large container, you can see that, which has been lined with a carbon black. Inside this we have taken a ore which has been dissolved with the cryolite, and they have maintained the temperature also, and you can see that at the bottom we have kept it the series of the anodes, okay, series of the electrodes we have kept, and this is nothing but a graphite anode, and this carbon lining is nothing but a graphite which is acting as what? Cathode. Okay, and also, you know, at the end, you know, the molten slag will be collected in the aluminum, which I have shown with the dark maroon in color, and let us see how this process will be happen. Okay, the purified alumina is mixed with the cryolite, that is Ne3Al(F6), which lowers the melting point and increases the conductivity of melt. So for the 1 mark, they can also ask which are the electrolytes are used in extraction of alumina by Hall-Heroult process. So the electrolytes are nothing but your cryolite, which is lowers the melting point of your entire ore and also increases the conductivity. Okay, so at the graphite rod, what are the reaction which has happened, and the anode, what are the reaction which has happened? It is very, very important. So see, at the graphite rod, you know what happened? The carbon combines with an oxygen and forms a carbon monoxide with the liberation of 2 electrons. Okay, similarly, the carbon combines with the remaining oxygen and forms a carbon dioxide with the evolution of 2 electron. These are the 2 reactions which has happened only at the cathode, that is at a graphite rod, okay, where the carbon combines with an oxygen and forms a carbon monoxide and a carbon dioxide respectively. And also at the cathode, you know, the steel vessel with a carbon lining where alumina will be get reduced to alumina, and overall reactions will be written like this. So at the graphite rod, you know, as I said, the carbon lining will be acting as a cathode, as we have kept the anodes, which is nothing but a graphite anodes, which is also there in the entire electrolytic cell, which will be receives the reduction by the your entire ore which we have taken in the reaction mixture. As a result of this, you know, we can expect that the aluminium, okay, which will be get reduced to aluminium plus 3. Okay, so or you can write that aluminium plus 3 state will be get reduced to aluminium by liberating with the 3 electrons. Okay, so this indicates that aluminium is undergoing a reduction with the formation of carbon monoxide as a catalyst, and thereby it forms a pure alumina. So this is all about the important question which has been repeatedly asked from the unit 6, the general principle and process of isolation of the element. Hope you all understood with the session. I'll come back with one more unit. Till that, take care and be safe. Thank you.